A ground fault circuit interrupter, or GFCI, is designed to protect people from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there is a difference of even a few milliamps, typically around 5 milliamps, the GFCI will trip, quickly cutting off the power. This difference indicates that some of the current is leaking to ground, possibly through a person's body, and could cause serious injury or even death. So, the first thing is that it is not uncommon for GFCI devices to trip even with very small currents. Given that the sump pump is tripping the GFCI after a certain amount of runtime, it strongly suggests a ground fault is developing. This means that some of the electricity is leaking to ground instead of flowing through the intended circuit. The fact that the GFCI can be reset immediately indicates that the fault isn't severe enough to cause permanent damage, but it's still a serious safety concern. Here's a breakdown of potential causes and troubleshooting steps. Firstly, moisture can be a major culprit in GFCI trips, especially in outdoor or damp environments. Even a small amount of moisture can create a path for current to leak to ground. This is particularly relevant to a sump pump operating in a pond. Check the area around the pump for any signs of excessive moisture. Examine the pump's housing, the wiring connections, and the surrounding area for dampness or condensation. If possible, try to dry out the area and see if the tripping issue resolves. Secondly, the sump pump itself could have a fault to ground. Over time, the insulation on the pump's internal wiring can degrade, especially in a wet environment. This can lead to a short circuit where current leaks to the metal casing of the pump and then to ground. A simple test involves temporarily moving the pump to a completely different location away from the pond. Plug it into a different GFCI outlet, preferably one that's known to be working correctly. If the pump still trips the GFCI in the new location, it confirms that the pump itself has a ground fault. If the pump doesn't trip the GFCI in the new location, then the problem is likely related to the original location or wiring. Thirdly, inspect the wiring. Even though 12-gauge wire is being used, which should be sufficient for a 15-amp circuit, there could still be issues with the wiring itself. Check the entire length of the wire for any signs of damage, such as cuts, abrasions, or exposed conductors. Pay close attention to the connections of the GFCI outlet, the breaker panel, and the pump itself. Make sure all connections are tight and secure. Loose connections can create resistance, which can generate heat and potentially lead to a ground fault. Fourthly, consider the age of the pump. Sump pumps have a limited lifespan, and as they age, their components can wear out and become more susceptible to faults. If the pump is several years old, it may be nearing the end of its life and could be developing internal problems. Fifthly, the GFCI outlet itself could be faulty, even though it has been replaced. While it is less likely, it's still possible that the replacement GFCI is also defective. To rule this out, try testing the circuit with a different GFCI outlet, preferably one from a different manufacturer. Sixthly, consider a process of elimination. Since there is another device, the aquarium air pump, on the same circuit, try disconnecting it temporarily. See if the sump pump continues to trip the GFCI with only the sump pump connected. If it doesn't, then the air pump could be contributing to the problem, even if it's not directly causing the trip. It could be adding just enough additional load or creating a slight imbalance in the circuit to push it over the edge. Seventhly, examine the location. If the problem is related to the original location, the issue might be with the wiring or the environment around the pond. Check for any signs of water intrusion into the wiring conduit or junction boxes. Make sure that all outdoor electrical connections are properly sealed and protected from the elements. Consider adding some sort of water diversion, like a shield or cover, to prevent water from splashing directly onto the pump or its electrical connections. If after trying all these steps the sump pump continues to trip the GFCI, it's recommended to consult with a qualified electrician. An electrician has the tools and expertise to diagnose the problem accurately and safely and can perform any necessary repairs or replacements. They can use a megometer, also known as a megger, to test the insulation resistance of the pump's motor windings and wiring. This test can reveal hidden ground faults that are not easily detectable with a visual inspection. It's important to address GFCI tripping issues promptly, as they indicate a potential safety hazard. Ignoring the problem could lead to electrical shock or fire. Ground faults can develop due to various factors, including moisture, damaged wiring, aging equipment, and improper installation. By following a systematic troubleshooting approach and taking appropriate safety precautions, it's possible to identify the cause of the problem and resolve it effectively. Remember to always disconnect the power before working on any electrical components and to consult with a qualified electrician if you are not comfortable performing the repairs yourself. Moreover, understanding the principles of GFCI operation and common causes of tripping can help to prevent future problems. Regular inspection and maintenance of electrical equipment, especially in wet environments, can significantly reduce the risk of ground faults and ensure the safety of yourself and others. Always use appropriately rated and weatherproofed electrical components for outdoor applications. Ensure that all wiring is properly installed and protected from physical damage. Keep electrical equipment clean and dry, and address any signs of water intrusion promptly. By following these guidelines, you can minimize the risk of GFCI tripping and maintain a safe electrical environment. Ground fault circuit interrupters are a critical safety device, and it's essential to understand how they work and what to do when they trip. Don't ignore GFCI trip, as it's a warning sign that something is not right. Investigate the problem thoroughly and take corrective action to prevent potential hazards. When a ground fault is suspected, a multimeter can be used to check for voltage between the ground wire and any accessible metal parts of the pump or the electrical enclosure. A reading significantly above 0 volts indicates a ground fault is present. However, this test should be performed with caution and only by someone familiar with electrical safety procedures, as it involves working with live circuits. Another consideration is the sensitivity of the GFCI. Some GFCIs are more prone to nuisance tripping than others, especially in older installations or with certain types of equipment. If the GFCI is tripping frequently and there are no obvious signs of a ground fault, it may be worth trying a different brand or model of GFCI. However, it's important to choose a GFCI that is properly rated for the application and that meets all applicable safety standards. Additionally, the National Electrical Code, or NEC, provides specific requirements for GFCI protection in various locations, including outdoor areas and near water sources. It's essential to comply with these requirements to ensure electrical safety. In the case of a sump pump air pond, GFCI protection is almost certainly required. The NEC also specifies the types of wiring methods and equipment that are suitable for wet locations. Use only wiring and equipment that are specifically listed for use in wet locations. This includes using waterproof connectors and enclosures to prevent water from entering electrical components. Proper grounding is also essential for electrical safety. Make sure that the electrical system is properly grounded according to the NEC requirements. This helps to provide a path for fault current to flow back to the source, which can help to trip a breaker or GFCI and prevent electrical shock. Regular testing of GFCIs is also recommended. Most GFCIs have a test button that allows you to verify that the device is functioning properly. It's a good idea to test GFCIs at least once a month to ensure that they are working correctly. If the GFCI doesn't trip when the test button is pressed, it should be replaced immediately. Furthermore, consider the overall load in the circuit. Even though the sump pump only draws 4 amps and the air pump is small, it's possible that the circuit is already close to its maximum capacity. Adding additional load to an overloaded circuit can cause the breaker to trip or, in some cases, can lead to overheating and potentially a fire. Make sure that the circuit is not overloaded and that the wiring is properly sized for the load. In addition to the above, electromagnetic interference or EMI can sometimes cause GFCI tripping. EMI can be generated by various sources, including motors, transformers, and electronic devices. If the sump pump or other equipment in the circuit is generating excessive EMI, it could interfere with the GFCI's operation and cause it to trip. In some cases, adding a filter to the circuit can help to reduce EMI and prevent nuisance tripping. Ultimately, the best approach to troubleshooting GFCI tripping issues is to be systematic and thorough. Start by checking the simplest and most obvious causes, such as moisture and loose connections, and then gradually move on to more complex issues, such as ground faults and EMI. If you are not comfortable working with electricity, always consult with a qualified electrician. Electrical safety is paramount, and it's always better to err on the side of caution. If you are unsure about any aspect of electrical work, seek professional assistance. Remember that GFCIs are designed to protect lives, and it's essential to ensure that they are functioning properly and that any tripping issues are addressed promptly. If you have aluminum wiring, it is known to expand and contract at a greater rate than copper wiring. Over time, this expansion and contraction can loosen connections, leading to increased resistance and heat, and increasing the likelihood of a ground fault. Ensure that if you have aluminum wiring, you use a proper CO/ALR connector. Also, consider that a neighbor's electrical equipment could potentially interfere with the GFCI. If a nearby device is generating significant electrical noise or transients, it could couple into your electrical system and cause the GFCI to trip. This is more likely to occur if the electrical systems are close together or share a common grounding electrode. Another point is that sometimes rodents can chew on electrical wiring, causing damage that can lead to ground faults. Inspect the wiring for any signs of rodent damage, such as no marks or exposed conductors. If you find any damage, repair or replace the wiring as needed. Also, check the weep hole of the pump is not clogged if it is meant to have one. A clogged weep hole could cause the pump to overheat and lead to a ground fault. If it is not meant to have one, disregard this step. And when replacing the GFCI, ensure it is rated to handle the amperage of the circuit in use. Installing a GFCI with a lower amperage rating than the circuit could cause it to trip prematurely. Lastly, remember that electricity and water are a dangerous combination, so it is essential to take all necessary precautions when working with electrical equipment in or near water. Always disconnect the power before working on any electrical components, and never touch electrical equipment with wet hands. By following these guidelines, you can reduce the risk of electrical shock and ensure the safety of yourself and others. If there is a chance the water level is too low for the pump to work properly, the motor can overheat, causing a trip.